Questions that an inhabitant of this world might ask a century from now. How could an expensive status symbol become a piece of trash in just a few years? How did someone's mobile workplace become a lifeless husk? Why would even new materials be considered to be garbage? And how were we even able to build the gigantic machines that powered this world? Where did we even take the energy from to make this possible? And to answer these questions with a question, will it really still take a century? I say it's time to rethink our approach to energy consumption. Let's repair and repurpose. Let's save at least some of the things that cost us so much to make in the first place. And in that spirit, let's see what we can find at the scrapyard here today. These green objects here seem to be rather large centrifugal pumps by the German manufacturer Vilo, recognizable by the color of the paint. I'm sure it could be extremely useful to have at least one of these pumps, but the motors are missing and they are also maybe a little heavy for anything I'm planning at the moment. Now what is that? Unfortunately empty, but I happen to have a half-inch wrench and an assortment of sockets, but no case, so this is the first thing that I will take with me today. This is an old forge blower or fan from a coal-fired forge. Unfortunately, parts of the motor are missing though, and this is beyond reasonable repair, I'm afraid. And what do we have here? This is part of a Wagner brand portable spray painting system. Very expensive, and I'm definitely keeping this. These two old timers here are both some kind of bending machines for sheet metal, I think. Especially the one on the front is beautiful, and if I had a huge warehouse, I would like to have it. But it's too big and too specialized to meet my needs at the moment. Here we have an old toolbox, and this is the style toolbox that, for example, my father has back at his shop, and that you will find in many old German shops, and I always wanted to have some, so this is a keeper. Here we have an old propane torch, it seems, and the writing on here appears to be Polish, I guess. Can any of the viewers translate? However, the smell of propane is in the air and I better get going. Another somewhat smaller toolbox of the same type. The tools in here are mostly junk, but I will keep the box itself. Paying the usual scrap price, this will be 1 or 2 euros, maybe. A really old air conditioner, probably from the 1970s, with a pretty massive compressor. We could build another air compressor, but I guess we'll have more than enough chances to find better parts for that in the future. And now, a viewer, one of you guys out there, sent me this Bosch hammer here, which he says is for 110 volts, which is why they can't use it at his workplace here in Germany, and they don't know if it even works in principle. Well, okay then, I'd say let's get her done. Let's start then with what is maybe best described as a portable turbine for spray painting. The idea here seems to be that you can do spray painting, for example on a construction site, without the need for a conventional compressor. The turbine generates relatively low pressure, but a pretty high flow rate of around 2,400 liters per minute, which equates to roughly 85 cubic feet per minute. It has a crusty old on-off switch on the back and an old power cord that has clearly seen better days. I'll definitely have to replace that. And in order to do that and to peek inside, let's open the enclosure. Here we have an easily detachable back cover with an exchangeable air filter. This is obviously where the air is sucked in. Taking off the cover and the grid on the back side is quite easy, and all you have to do is unscrew a bunch of screws. Here we can see the input side of the turbine or fan. But unfortunately, there seems to be no easy way to proceed with the disassembly without bending some of the sheets that grab behind them. So we'll stop for now, but we'll have a teardown by other means in just a few minutes. Now the cable guard is loosened and the old wire removed, and then a new power cord is installed. And I'm putting the whole thing back together. But how much is 2,400 liters per minute really? Well, what better way to grasp it than a practical visualization? Okay, I guess you get the idea. It seems to work. Now, of course, just the turbine is not enough for spray painting. You also need a hose and a paint gun. And what I don't like about Wagner already is that all the connectors are apparently proprietary. So I looked online for a used hose and I got one for 30 euros. And a new one is around 120, by the way. The good thing is that the hose came with another used turbine. I was very happy about that because this way we can still make a teardown. But for now, let's put the second turbine aside and let's try to get this one to the point where we can do some spray painting. I don't own a genuine Wagner brand high volume low pressure paint gun, and one of those is around 200 euros, by the way. So I picked up some standard parts from a store for air compressors and I'm now trying to build an adapter for a normal quick connector. I first cut off a piece from this reducer to make it lighter. I also shortened this nut for the same purpose. I solder the two pieces together and do some finish work on the lathe. I apply some Teflon tape and connect the adapter to the hose. And now I prepare different HV/LP paint guns to the turbine and test the setup outside with actual paint. And the adapter holds and the setup does work. I'm sure there is room for improvement though, and I will keep my eyes open for a genuine Wagner paint gun that was built for these conditions. So let's proceed with taking apart that second unit then, and let's see what we find inside. I bent the sheets to the side, but only so far that I could theoretically bend them back, and I removed the fan. It just seems to be a pretty powerful blower. Manufactured by the Lamp Corporation from America. I think this is probably just a very strong vacuum motor. It sure sounds like it. The enclosure was cast from metal, by the way. This is not plastic. And here we have a speed controller for universal motors that I built a few years ago. Remember that forge blower we saw earlier at the scrapyard? Maybe it wasn't such a big problem that it was broken after all. Despite the fact that I like my workplace very orderly, I haven't managed to take care of everything yet since I moved into this place. Good that I found this ratchet case and overall 3 of these old toolboxes on one random day when I have been looking for those for years. The ratchet case is not perfect, but pretty well suited for my random assortment here. The 3 toolboxes are cleaned with just WD-40 in a rag, and now an hour-long process of sorting through these tools begins. These boxes are not necessarily perfect, but they are rugged and won't break after just a few years like modern plastic boxes. And they can handle heavy metalworking tools pretty well. Let's get to the next big project then, getting that Bosch hammer running. Thanks again for sending me this, by the way, you know who you are. Now, this hammer drill might well be 20 years old, but it seems to be almost unused. It's a Bosch 220 SRE, but has Asian characters on it. I suppose that's Chinese, right? No idea how this made its way to a German company. Says it's rated for 115 volts AC at 50 or 60 Hz. Now, as you might know, Germany has 230 volts AC nominal line voltage at 50 Hz. The power cord is obviously not original, and we will replace it and have a look inside while we're at it. Remove this back cover and you can see that the speed controller, filters and brushes look like new. We find two date codes from 1997 though. Now I don't know if the machine still works. It might be that it was plugged into a 230 volt outlet and was damaged. I can't see any obvious damages though. And in order to prevent that from happening again, I will now add an American style power cord to this machine. I happen to have this adapter from a German Schuko type to an American outlet with protective earth. And I will use this cable here. I know that the third connector, the protective earth, is not needed for this machine, but it's all that I have in terms of 115 volt connectors. But in order to use the power drill, we will still need a 115 volt power source. And that's why I will use this opportunity to build something I wanted to do for a long time. A 230 volt to 115 volt adjustable isolation transformer. And I'm doing that using 90% salvaged components. This is an old German-made transformer with a 110 volt secondary. It should be able to handle a few hundred VA, but will also be cooled by a fan. I also have this 120 volt variac that was once sent to me by another viewer. It was made by Staco in Dayton, Ohio. So today my greetings go out to the viewers in Ohio. Anyone? Leave a comment. The next thing I need is an enclosure with a handle that is big enough. I think I have something on the shelf. The old stickers. The remaining glue and dirt are removed with WD-40 and different abrasive materials. The paint on the front is removed because it is really heavily damaged. A Schuko outlet is installed into the hole left behind by the discharge port of the blower. Now a number of holes are drilled and the variac is installed. Why even have a variac? Well, the reason is that I will never have another use for a 120 volt variac than in this application, because it is not suited for 230 volts mains voltage. But adding the variac will turn this device into something much more useful than a simple converter. It will turn it into an adjustable AC power supply, making it much more useful in the lab. Now we need a knob for the variac, and of course I have a box with used knobs. This one is beautiful, but the axle on the variac is still a little too wide. Therefore, we increase the bore in the knob using the old lathe. What a useful tool it has become here in the shop. This knob also needs a new M4 thread, since it was used with another system where a bolt actually penetrates the axle and is then fastened on the other side. Therefore, I hand cut a thread into the knob. Now the mains transformer is fastened to the bottom metal sheet. It is needed to step down the voltage, but unlike the variac, it also provides electric isolation. In German, galvanische Trennung. A normal variac, on the other hand, is an adjustable auto transformer that doesn't provide electrical isolation. If you want to know more about this stuff, watch my video series about building an isolation transformer. You can find that in the video description. Even the screws are used to fasten the transformer are salvaged. They are ancient. Last but not least, a fan is installed that will cool down the mains transformer under heavier loads. The fan runs on 230 volts directly. About how we're going to wire this up, from the most important things to, let's say, optional things later. Installing a new power cord will be necessary. It'll then be connected to this on-off switch. The output side of the on-off switch will go to the primary of the mains transformer, with this fan here being connected in parallel. So once you switch this on, the fan will blow. The 110 volt secondary is going to be connected to the variac, and then one of the leads coming from the mains transformer and the tap on the variac are going to be connected to this outlet here. I'm also probably going to connect these two mounting posts here in parallel. That's just so that you can connect devices that don't have a plug. The two remaining posts here are going to be connected to the 32 volt secondary, and I'm just doing that as a gimmick really. The transformer has the secondary, and we might as well lead it out of the enclosure. Maybe we can use it for some experimental setup one day. Then there are some optional things that I would recommend to do, and that is to connect a small fuse on the primary side. We could probably do this here. Then connect a over temperature switch on the transformer, and we could also insert small fuses on the output side. Now, I've done all these things with my isolation transformer that you saw earlier in this video. And if you want to have more explanations about these things, then just watch the older episode on how to build these isolation transformers. You can find them in the video description. The two halves of the enclosure are joined and the remaining wiring is completed. The back side is closed and the bends in the enclosure are corrected. Test with a multimeter. So, I'm happy with today's results. This episode was a wild mixture of ideas, hacks and builds, and maybe less classical repairs, but in reality it is just often necessary to be creative to make use of things rather than just replacing parts. However, I really hope you liked this video, and if you want to see more episodes with Scrapyard Repair-A-Thons, then you should absolutely give this video a like to give me a clear signal to go full steam ahead with more content like this. If you want to support this effort, visit my Patreon and become a supporter. See you soon.